understanding of how permutations and combinations are related to each other and to the multiplication principle. There's a formula floating around in the background. I'll give that kind of relationship to it too, but really more direct ways to think about this just as you're making selections. So in the first example, we have 7 items, we're taking 4 of them, and we're saying the order matters. So how many options would you have for the first item? Well, there's 7 items, so you have 7 options for the first item you select, multiplied by how many choices for the second item. Well, since you already took one, you only have 6 options left. Then the next one would have 5 choices remaining, and the last one would have 4 choices remaining. 7 times 6 is 42. 42 times 20 is 840. So you're looking at 7 items, taking 4 where order matters. You can do this in 840 different ways. Now the formula, if you see the permutation, effectively when you plug in your numbers, you're going to end up getting a 7 factorial over a 7 minus 4, which is a 3 factorial. So you get a 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And notice that after cancellation, you're actually getting the exact same numbers. So the multiplication principle makes it, in my opinion, a little bit more obvious. Now, what if order didn't matter? What if order didn't matter? Well, if order didn't matter, then that means that you have way too many options that you counted here, right? Think of letters. You chose A, B, C, and D, and another one that you counted was choosing D, C, B, and A, but those are the same ones. So if you don't care about the order, we have to somehow divide out by a certain number. So we're going to take the answer we got the last time, which is that 840, and we're going to divide that by the number of ways that we could rearrange those 4 items that we already picked. So that would be 4 times 3 times 2 times 1. So in other words, we end up getting 840 divided by 24. So let's see if we can do this here. 840 divided by 24. Let's divide out the 2 first. 420 over 12. And then divide by 6 and go 70 over 2 and then go 35. So the final answer for this one would be 35. Notice that there's far less. Now check out the formula, the magic of the formula here. If you had done the formula, you would have what you had last time. You'd have a 7 factorial. You'd also have the 3 factorial, but you'd also have a 4 factorial. So watch what happens as I write all those ones out. 7 times 6 times 5 times 4 times 3 times 2 times 1 over the 3 factorial. I'll write it over here so it obviously you can see how it reduces. And then the 4 factorial, well, that's just the extra numbers that we needed on the bottom anyway. So again, with reduction, this timesing, this multiplication principle is actually leading us to the exact same answer. So 840 up here and 35 much smaller down here. So why don't you pause the video and try to do this one on your own. Imagine you had 9 items and you're taking 3 of them. Okay, assuming you gave this a good old shot here, the first example was where order matters. Order matters, so you have 9 choices for the first one, 8 choices for the second one, 7 choices for the third one. So we end up getting 72 times 7, which is 14, and then 49 plus 150, so you get 504. So there should be 504 options if you did 9 times 8 times 7, and that's the permutation. And now the fancy way to do the combination would be to say, well, if order didn't matter, order does not matter, then you would be doing a combination, and based on what we saw last time, now I can do 9 times 8 times 7 over, well, how many items were there? There were 3. So 3 times 2 times 1. Notice that in this form it's a lot easier and faster to reduce these to a 3, reduce those to a 4, and 12 times 7 is simply 84. So the answer for the combination would be 84.